Well, thanks very much for inviting me. I've been giving talks at this series over probably the last 20 years, and it's always fun to come back. The topic today is human-centered methods for improving API usability. So what are APIs in this context? APIs stand for Application Programming Interfaces, and by API we are trying to use a very general term to mean things like software libraries, toolkits, frameworks, SDKs, software development kits, and nowadays we also are including things that are often called middleware or web services. And we also want to include internal APIs. So if you're on a large software project, you will be using lower level features, which are usually exposed to you as an API. The key motivation for an API is so that you can have some software resources that you don't have to personally write that you can reuse from others. APIs are surprisingly important and valuable. I didn't realize this when we started, but there are thousands of APIs just for the web. There's a site called programmableweb.com, which lists over 17,000 APIs with like 100 new ones appearing every month. There's a consulting company called Apogee that says 77% of companies rate their APIs as a really important part of their business model. And in fact, the market for API web middleware, and this is just for the web, was $5.5 billion in 2014. Another way of recognizing the importance of APIs, I was just visiting Amazon, and they mentioned to me that if you go to their financial statements, most people think of Amazon as a marketing as a store. In fact, the Amazon store lost $174 million in the last 6 months, but AWS, which is their cloud platform, made $1.8 billion. So really, Amazon is a web services company that happens to have a little store as a side business. And other companies are starting to recognize that this is a key part of their potential business. Part of the evidence of that is Google actually bought the Apogee consulting company for $625 million last year. So why should we use human-centered methods for APIs? Somewhat controversial. My group thinks that we can treat programmers as if they're humans. And therefore, we can use techniques that we have as an HCI community established over the last 20, 30 years as successful ways of understanding people, of making things that work better for people, and evaluating what the people who are developers are actually experiencing. And we call this developer experience, DX or DevX, as kind of an analogy with UX, which everybody understands as an important thing to start optimizing. And APIs actually have the word interface in them, and in fact, they are the user interface between this body of code and the programmers who are trying to use it, so we can think about how to deal with that. I like this definition of programming. If you think of it, programming is basically the human activity of translating a task that you have in your head that you're trying to get the computer to do into a representation that the computer can understand. And our claim is that the smaller this transformation is, the closer the mapping, the better off you'll be. And other people have called this similar things. So in HCI, we always say if the user interface doesn't work for the people, it doesn't actually work, even if it doesn't have any bugs. You can say the same thing about APIs. Even if the functionality matches what people expect, if it doesn't actually operate as people want, then you should not count it as working. There's been a number of reported examples where the incorrect use of APIs, where people misunderstood how to use an API and used it incorrectly, resulted in bugs and even really significant security holes in software. As I mentioned, APIs are now a big business, and it's starting to be recognized that the usability of the APIs are key influencers of whether people are going to use your APIs or not. And so this translates into millions or billions of dollars for certain companies. And so API's usability actually is an important business asset, business advantage. Another thing that's important to recognize is that people don't just use one API. They're bound to be using multiple APIs, and they have to work together. And finally, even if you don't have this really dramatic mistake in the usability of your API, it can still be a pain. Andrew McVean from Google wrote this article where he talked about how people can have death from 1,000 paper cuts, that just annoyance after annoyance in their APIs eventually makes them so sick of it that they give up and try something else. HCI, human-centered methods, is actually quite a broad category. Most people think of human-centered methods as just usability evaluations or A/B studies, but in fact, in the HCI master's program at CMU, we teach all these methods, plus many more, and they help you answer a wide variety of different questions you might have about people. And we found that virtually all of these can be applied to APIs. In fact, we've applied these methods across the entire lifecycle of an API. So at the early stage where you're trying to envision or plan, we've used techniques such as contextual inquiries and interviews and surveys, lab studies, and something called data mining, where you take a big repository of software and look through it to see what kind of patterns you can find. And all of these help you understand what the real problems are. At design time, we have a variety of methods to help you design your APIs after you've figured out what they should be doing. And this includes a natural programming process that we invented in my lab. We also use graphic and interaction design, as well as paper prototyping, standard HCI methods that most people wouldn't imagine you can apply to APIs, in fact, work perfectly well. Then you go ahead and implement your APIs, and then you need to evaluate them. And we, again, use fairly conventional HCI methods, heuristic analysis, cognitive dimensions. We do usability evaluations, and sometimes we even do A versus B studies of the APIs themselves. We haven't used these in my lab, but Andrew McVean at Google has reported that the key techniques that they use are automatic analyses. So they have tools that will automatically run through an API and find certain problems, in analogy with the lint tool for C. And they also make heavy use of peer reviews or design reviews or code reviews to look at the APIs. And then finally, after release, there are lots of different mechanisms you can use, log analysis, error reports, feedback from users, and so forth. So I mentioned that we invented what we call the natural programming elicitation technique in my lab. This was quite a long time ago we started doing this. And it's basically an idea to try and understand how your API users are thinking about the problem you're trying to provide an API for. And so what we're going for is, what are people's mental models? What are people's vocabulary? How do they talk about this particular design? And we tend to use blank paper tests, where you just give people a piece of paper and say, imagine you had an API for X. How would you want to use it? What would be some of the objects, classes, methods, and so forth? The trick is to figure out a way of prompting for this without giving away the answers. So if we say, what would be a good object for sending mail? People will say, send mail. And then you really haven't learned anything, because they just use the words you just told them to use. So it's really tricky to come up with ways of asking the questions that don't give away the answers. And that's kind of a lot of the interesting research around this method. But we have done things like understanding the API architecture, trying to understand the vocabulary people want to use, and also which methods go on which classes. So I have a much larger scale project called the Natural Programming Project that we've had this name since around 1995. But I've actually been working, as James mentioned, in the area of making programming better since as far back as '78. So the goal in general of the Natural Programming Project is to make programming easier. And the way we try to do that is by making it more natural. And we don't mean natural like natural language, so we're not programming in English or French. Instead, we're trying to understand how people think about it and make it closer to that. And we obviously have to do studies to understand how people are thinking about it. We use these studies to guide designs, and we create new languages, new tools, and again, new APIs. And then we iteratively evaluate and refine these. And we target 3 classes of programmers. There's expert programmers, which is most of our work. We also, to some extent, look at novice programmers, which we define as people who are trying to become expert programmers, so people who are in school, for example. And separately, there's a group we call end-user programmers. And these are people who, one colloquial way of thinking about it, are people who program because they have to and not because they want to. So most computer scientists enjoy programming. That's why they went into it. Software engineers and so forth, and they program because they want to. But there turns out to be a really large number of people. In fact, in a survey that we did way back in 2005, and Chris Graffiti actually updated the survey just this year, it's pretty consistent that as many as 13 million people say they do programming at work, even though only 3 million of them are trained as professional programmers. So there are lots of different jobs that involve doing some kind of programming. For example, writing web pages, you might write some JavaScript. Doing spreadsheets, you might have to program. Doing database accesses, doing data analysis, all sorts of different kind of tasks require you to do programming. And so there are lots of people who do this as part of their job, not necessarily because they want to. And of course, there are scientists and engineers as well. And so one of the key points of this is that if you're designing APIs or any other kind of tool for programmers, it's going to be used by many people who don't necessarily have a software engineering background. And so you really need to think about how other kinds of people are going to be approaching the tasks that you have available for them. Another way I like to describe this is as a gentle slope system. And so this is a kind of a characterization I've been using for many years. The vertical axis is how hard it is to do something, and the horizontal axis is how much you can do. So thinking of Java, it's pretty hard to get started. So the y-intercept is quite high. There's a lot to learn if you want to be a Java programmer. But you can't do very much with Java until you start learning APIs. And so that's why there's this wall here that after you learn Java and you're really good at object-oriented programming, that's not enough. You have to learn how to use swing and the listener pattern and all sorts of special other things one needs to know to use swing effectively, or the networking package, and you have to learn sockets and all these other kinds of things you have to learn its APIs. So that has a very high ceiling. You can do anything you want in Java, but maybe we'd like to have a lower threshold so people can get started easier. So the web is a good example of something with a lower threshold. You can use Dreamweaver or templates from different manufacturers or WordPress or whatever to get started, and you can go along pretty well. And then all of a sudden you realize you need to learn CSS and HTML, and that's a wall that you'd have to overcome. And then after that, you want to make your page dynamic or do some data checking, and you have to learn JavaScript, which doesn't help very much until you learn a million libraries on the client side and all the JavaScript libraries. But then you want a database, and so you have to learn server-side stuff. And we show that line crossing the Java line because not only do you have to know how to do this stuff, but you have to know how to coordinate these 5 or 6 different languages together. This is machine learning, same kind of thing, that there's a million little libraries you have to learn and have to figure out how to get them to all work together. And it's always a lot of fun to put your own systems on this chart and see where you think they fall with respect to the other ones. But none of these are close to the ideal, which we draw like this. Basically, the idea is that no matter where you are, you can get started right away. There's not a big barrier to getting started with this API, and everything you want to do that's more sophisticated only requires a little increment of learning. And so you don't get these barriers, these big walls. You get this nice gentle slope all the way through, and you can keep going and do as much as you want. So this graph applies to APIs, it applies to programming languages, kind of any kind of tool that lets you do sophisticated development. And the nice thing about this goal is that I've been using this chart for years, and we don't really have much hope of actually achieving this goal. So this means I don't have to worry about retiring. I can just keep plugging at this forever, and so can my students. So there's plenty of room between where we are and where we want to go to foster lots of interesting research approaches. So our study of APIs in particular started with Jeff Stylos' PhD thesis, where he graduated in 2009. He's now a lead API designer at IBM. And he interned at the API usability group at Microsoft in the Visual Studio group with Stephen Clark, who kind of invented this area of API usability. And his thesis was, Jeff's thesis was a lot about which programming patterns turn out to be the most problematic and most usable. And we looked at learnability, error rates, preferences, and so forth. We studied three different patterns and also collaborated with SAP. And then recently, Google has funded us to do some follow-on research, which I'll tell you about as well. So Jeff's first study, he called the required constructor pattern or the create set call pattern. And so this is the difference between being able to create an empty object. So here we're creating a foo, which is empty, and then we're filling it in later. So this is the create set call pattern. And that's as opposed to having a required constructor. So in this case, when you create a foo, you have to provide all the data that foo needs, and then you're not allowed to change it afterwards. Or maybe you are allowed to change it, but typically you wouldn't. So if you know anything about Java, then a string class is immutable in Java. There's no way to change a string after you've created one, whereas most of the other classes are mutable, and you can create empty ones and fill them in. So it turns out in our study that everyone preferred the top one, the create set call pattern, and it seemed to be that it fostered exploration, it fostered learning better, because people could learn all about foo without having to get distracted and learning about bar first. But on the other hand, the security researchers were very worried about this because the immutability pattern, the second pattern, is actually considered much more secure and much better for threading. If you imagine you have multiple threads, if you have an immutable object, it's perfectly fine to share them amongst the threads because nobody's going to muck them up for anybody else. And so this is a better approach for security. And so recently we had a follow-on research where we showed that if you really wanted immutable objects, there was an effective way of doing that, which we presented at the Software Engineering Conference last year. But it was a language design, not an API, so I'm not going to talk about it anymore. Probably the most famous study that we did was on what's called the factory pattern. Normally, when in object-oriented programming, when you want a new object, you say new object. So widget W equals new widget. In the factory pattern, you're not allowed to do that. You're required to go off and find this other thing called the factory and ask it for a widget. So in this case, you say f.create me a widget. And so this means that when you're trying to do stuff with widgets, you also have to somehow figure out that you need this other class as well. Very common pattern. It's used a lot in Java and .NET and SAP. And if you go to books, they actually recommend using this pattern. In contrast, we found it to be really problematic. That programmers found it very hard to use. Nobody ever expected it to be there. And when it was there, it had a measurable impact on performance. It was 2 to 5 times slower and more problematic to figure out how to use. Another study we did was on method placement. So in any real API, you're going to have multiple classes that are required, multiple different groups of functionality, and you have to figure out as a programmer how to put them together. And that is often very difficult. So here's an example in Java in the mail program. There's 2 classes that coordinate together. One's called the transport class, and the other's called the message class. And you, as an API designer, have to pick one to put the send method on. So which one would you pick, right? So usually at this point, I ask the class or the audience, so how many people think it would be a better design to put the send on the transport class? Okay, 4 or 5. And how many people think it'd be a better design to have the send on the message class? Nobody? 2 or 3. And all the other people who didn't vote, well, if you were an API designer, you're really not allowed to abstain, right? You have to make a decision. This is not one of those things where you can just say, well, I don't care. I'm not going to put it anywhere, right? Because you need a send method or else you can't send your mail. So, you have to really make a choice. And so it turns out in Java, it was put on the transport method, but everybody expected it to be on the message method. Everyone expected to be able to take your email message and send it somewhere, because that's kind of how you talk about it. And the fact that it was in the wrong place actually was very confusing to people, and they would go to the message class and they couldn't find the send method anywhere. So now they were really confused about how they should go about sending emails. And it turns out that this had really significant impact on people's performance, between 2 and 11 times slower, as well as making it much harder to know what to do. Another interesting observation is that the naming of classes is often very problematic. So in Java, if you want to do something to the disk, you might think in your head that you want to deal with files. And if you go and search the class hierarchy for file, you'll discover it's an abstract class that you can't actually use, right? It's an interface or whatever. And so it'll say, oh, you can't use me, but I have 325 subclasses, pick one of those, right? So that's not particularly helpful. You have to know that you need to use a stream buffer, which is not anybody's first guess of the name of the thing you want to use. So this kind of object-oriented design where you put the name everyone thinks of at the top seems to make perfect sense from kind of an object hierarchy point of view, but from a usability point of view is really a nightmare. So we leveraged all of this research into a really fruitful multi-year collaboration with a software company called SAP, which is based in Germany. It's actually one of the largest software companies in the world that nobody's heard of, because they only do back-end software. So software that runs big corporations like universities and. Yep. So this is. So there definitely are problems with SAP software, and somehow they needed us to tell them what the problem was here. So this was back in the days before REST. Everyone was using web services called SOAP, which stood for Simple Object Something Protocol. It wasn't simple at all, which is why no one uses it anymore. And this is their actual names of some of the methods in their web services. It turns out in Java, there's a limit of 255 characters on ID names, and they'd run into that limit. And this is looking at their APIs in an IDE, and you'll notice the first 6 look identical. In fact, there are differences way over here somewhere, and if you hover over them, you can see that it actually shows you less of the name when you hover over them. And there's no horizontal scroll bar on this thing, so you really just are guessing. There's no way to know which one you're getting until you get it. And even when you do get it, it's really hard to know which one you've gotten, because the differences are all in the middle of these long names. And so anyway, somehow they needed us to tell them that was a problem. Their documentation was also problematic. So we did a map of all the different parts of their documentation and what you had to do to navigate from the top down to finding the actual name of an operation that you wanted. And this shows some of the paths of some of our users went, and there were lots of cycles and dead ends and misleading parts of the documentation. One interesting observation is that at some point the documentation changed color from orange to blue, and everybody gave up immediately and figured they had left the documentation because of this design color change. And in fact, if they had pushed through, they would have gotten back to orange and would have been able to find it. Another thing that we noticed is it's really important in this situation to understand the domain, right? So this was for business, and you notice that all the documentation has these things like SCM and SRM, and if you're a business person, these make a lot of sense. If you're not, you don't know what these acronyms stand for. It turned out that non-business people had no hope of navigating this documentation and finding anything appropriate. So what would you do with this information? If you know that APIs are problematic, ideally you would change them, but we as researchers are not going to have much luck changing the Java APIs. And also, as an API designer, you may have other things that you're trying to optimize, not necessarily entirely focusing on usability. It may have to be backwards compatible. It may have to have higher performance. And therefore, we can think about tools. So how can you use tools to fix some of these problems with the APIs? And so we built these 7 tools, all of which have wonderful gemstone names and acronyms that you'll see, and that help you with these kinds of problems. So the first one is Mica, making interfaces clear and accessible. And this was right at the beginning of the era where people recognized that Google was the super best way of finding documentation. And so whenever anybody had a programming problem, they would type it into Google and find the appropriate examples and documentation. And this was right at the beginning where that was starting to be done. And we recognized that this was kind of a totally new paradigm of ways to have documentation. And maybe we could make it even better. So what Mica does is it takes the Google results and processes it to provide more information. So it provides a list of all the keywords that it finds in the returned values. And you can hover over the different keywords and find which ones describe it. It put this little icon near the results that had code examples, because everybody loves code examples. And many of these don't have them. And so this way, you can augment the results that it gives back to make them more useful for programmers. And this obviously is a ubiquitous kind of thing that's done now, but we were really the first people to show it. And happy to say we recently won an award. This was just 2 weeks ago. And here's Jeff and me winning this award in October for this paper as the most influential paper. And Jeff's getting grade 2. That happens to students, they get older too. So Jadeite is the next tool we built, Java API documentation with extra information tacked on for emphasis. Jadeite takes the Java doc and tries to make it more useful using some of this kind of knowledge. So one of the things it does is to make the names of the classes bigger based on how often they are used. And so this would guide people to using the right classes to start with, because there's just otherwise a really long list. Remember the problem about where the send method should be? So this green thing is what we call a placeholder, that in the message class, you can put this pretend version of send, which says, oh, there really is no send here. Go off to this other place and find it. So the idea is to help people exactly where they need the help without trying to put it somewhere else that it doesn't actually exist. And we also scoured the web for examples of how to use the class and provided those, and also showed which other classes tend to be used together. So remember, you need to use the transport class with the message class, and so we tell people about that. So wouldn't it be nice to have that information directly in the IDE and the tool that you're using for editing your code? And so that's what Calsite does. The idea here is that we just bring all that information into Eclipse. So while everybody's favorite way of doing coding or exploring an API is by typing dot and looking at the pop-up autocompletes. And so we wanted to add more information into that pop-up menu. And so that's what Calsite does. In this case, in a typical, if you ever tried popping up the autocomplete menu after an equal sign, you'll discover not much happens. It's really pretty useless. And that's why it doesn't come up by default. It only comes up by default after a dot. But you can pop it up anywhere you want, and you can see what it will tell you. We augmented that menu with a lot of extra information, like how to use sockets to get one of these objects to exist, how to use the factory pattern. And it brings in a lot of the other information into the pop-up menus as well. So if you go to the message class and pop up the menu, send will be there, even though it doesn't really exist. And it'll tell you how to go off and find the real code. So that Jadeite and Calsite were based on scouring the web for examples, and that obviously works really well for Java, but it won't work for most other tools that are poorly, that aren't widely used or which aren't comprehensive. And so Desite is another kind of boring rock, but it was an interesting system for design annotations for complementing interfaces targeting effectiveness. Was by a visitor who came over, and the idea of here is to use the Java annotation mechanism, which is surprisingly flexible. And in Java annotations, you can add an @ sign and then put kind of anything you want, and then you can run processors at compile time that will check things and generate data and so forth. So the idea of Desite is you annotate things like factory patterns or helper functions, and then it will generate a plugin for you that can then be used in your editor, IntelliJ or Eclipse or whatever, in order to help you in the same way as Calsite. But it also supported other things like helper methods, object builders, static factories, decorators, composite classes. So there's a bunch of other patterns that are hard to detect by scouring the web, but which the developer knows they're doing, and so this makes it a lot easier. I had a visitor from Germany who had a system in German called Euclid, which is German for Euclides, which is another gemstone. He luckily made us an English acronym, or we wouldn't be able to tell you what it was. And the idea of this is to deal with the common case that programmers like to copy and paste from examples. And so what Euclid does is it helps keep track of where you copied the code from and how it should automatically adapt it from the source to the destination so it fits in better with your destination. And so it can do some static analysis in order to help you update the code to better fit. Graphite is a cute little plugin that's to help you with constants, literal constants. It turns out there are a lot of special constants you need to do in languages, like if you want a color value, what kind of color should you use? And this will basically pop up a color wheel and let you pick the color like you would in a graphics editor, but instead it'll just plop into the code. And it also worked for regular expressions. Then finally, appetite is associative perusing of APIs that identifies targets easily. The idea of this is to kind of look at the documentation sideways. It's kind of a new way of looking at documentation by association. And the goal of appetite is that maybe you have the question, which classes have a read method? And so you just click on read, and that shows you all the classes that have a read method sorted by popularity. So the most popular messages are, most popular classes are bigger. It also answers the question, what other methods are typically used with read, and they appear here, or which actions do read usually associated with, and so forth. And so by clicking on things in one column, you get a bunch of associations of different types in the second column. And then you can keep going as far as you want, and this will provide information that's associated with each of the actions. So that's kind of where we were. And then recently, a former student who I was on their thesis committee went to Google and said, we really care about API usability. Wouldn't you like to start a new project studying modern web service APIs? And so that's kind of fun. And so the first two projects we did were to compare API style guides and interview a bunch of API designers. So this style guidelines we just presented Monday at the Plateau Conference in Vancouver. And the idea of this is that a surprisingly large number of companies will publish guidelines. So you probably heard of Java guidelines or the Apple style guidelines. So these are style guides for user interfaces, but they're also style guidelines for APIs. And there's a surprisingly large number of them. We found 40 of them fairly quickly, and 32 of those were about these REST APIs, the modern style of providing web services. So we were wondering, what people are saying about REST APIs and how much they agreed and disagreed. So these are the 32 ones that we analyzed in depth in alphabetical order. In the paper, that has the full URLs of all of them if you want to see more detail. Some of the big names are there: Amazon, Google, IBM, Microsoft. Notable missing are Facebook and some of the other big API companies. We found some of these in a website called apistylebook.com. Other ones we just found with Google search. It's also interesting to see the giant differences in the size of these. So the Google APIs are trying to be quite comprehensive and explain kind of all of the things you're supposed to do and not do as a Google API designer, whereas other ones that are particularly short, like REST cheat sheet, are intended to be kind of read from cover to cover and just give you a sense of what sort of things you should be thinking about. We looked at all the things that all the guideline sets said and collected their recommendations into categories. And so these are the categories of guidelines that we found, and they're sorted here by the number of different guideline sets that mention that particular category of problem. So 30 of the 32 guideline sets mention status codes. So the paper talks about most of these, but here I'm just going to talk about a few that we found particularly interesting. So all of the APIs have to deal with versioning. You have a new version, and that works slightly differently. How do you tell API users what the version is? These differed significantly across the different guideline sets. Some had the typical 3-level versioning, like 2.4.1, where the last one was either a patch or a draft number. Some just said to use 2. One just said to have a single number, and one said don't use numbers at all, use dates instead. They also had different locations where they wanted you to put the version. 11 of them said it should be in the URL, like here. 8 of them said it should be in the HTTP header and not in the URL at all. And then one said you should put part of it in the URL, and the other part should be in the parameter and the body of the message. So surprising amounts of differences there. Backwards compatibility is really important. So when you have an API and you need to change it, should the change be done in a way that code that's using this API will not break? That's obviously better. Some of the guidelines mentioned what it means to be backwards compatible, what it means to be a breaking change or a non-breaking change. And a number of them mentioned Postel's law, which is kind of a description of the web and web browsers, how they will try and be generous and accept kind of anything and try to deal with it. Liberal in what you accept and conservative in what you send out. So this is a good idea for APIs as well. Naming was interesting. So the Google API has very specific recommendations for particular words to use for particular kinds of things, whereas virtually none of the other APIs picked particular words, although a lot of them had something to say about parts of speech. So use nouns for this kind of thing and use verbs for this other kind of thing. Because obviously in English, you can mix those up, and that gets to be confusing. So they said, always use nouns for object names or something like that. And then there's a lot of differences in what kind of case to use, like uppercase, lowercase. Camel case, I think we've all seen a lot in various kinds of code. That's recommended by some people, as opposed to snake case, fun name, and that's where you use underscores. And then for URLs, where you're allowed to use hyphens, apparently that's called kebab case, like a shish kebab through the middle. I never heard that, but that's fun too. So you can use kebab case or snake case, and surprisingly lack of consistency. These recommendations are all over the place with the different guideline sets. Everybody said documentation is good. No surprise there. And everybody's in favor of having good documentation, but there was controversy about whether the documentation should be automatically generated or not. So web service APIs are basically about the information sent over the internet, but the consumers are in typically a wide variety of languages. So many APIs have to be implemented in JavaScript and maybe in regular Java, maybe in Python, maybe in C, C++. If you're talking about server side, then again, there's a whole other collection of languages, Dart, Rust, Go. So some of the companies have to have the same API implemented for 10 or 15 different languages. And that can be really difficult to manually create those. And so there are lots of tools that automatically will create your libraries and then create the documentation that goes with it. And so some of the guideline sets were in favor of doing that to make sure that they're consistent. On the other hand, that documentation is known to be problematic, so some of the guideline sets recommended against doing it automatically, and one said, well, do both, have it automatically generated and then manually fix it, which kind of defeats the whole purpose. And one tool that's starting to be popular is called Swagger, which is a public tool that people are starting to use. It's also called OpenAPI. So that was fun, but we really wanted to learn more about why people were making these recommendations and what designers were thinking about. And so we ran an interview study so far with 14 API designers across 4 companies. I'm not allowed to tell you who they are because that was confidential. We promised them confidentiality, but it was pretty extensive interviews with each one, 1.5 to 2 hours each. And we were able to get quite experienced API designers. So a mean of 9.1 years of designing APIs, ranging from 1 to 18. And they were also obviously really experienced programmers as well, a mean of 16 years up to 28 years of programming. And then we had a fun little workshop. It was kind of a meeting like this where we got to discuss API design with 50 different designers at the same time. And we are in the process of trying to recruit a few more to interview. And these people represented APIs in a wide variety of situations, old-fashioned, in some sense, C++ APIs, Java, Dart, C#, and of course, many of the modern REST APIs as well. And some were for internal use, and most of them were external or externally visible. We asked people what the size of their API was, and they found this very hard to answer. How do you measure the size of something like this? And typically, the answer they would come up with is how many methods they had, so 20 to 300 methods. But another answer is how many users they had. So the kind of minimum was hundreds of users, and the maximum was millions of programmers using their APIs. So obviously quite significant impact. We asked them what it meant to be a high-quality API, and the #1 answer was simplicity, typically meaning easy to learn, only does one thing, does it very clearly. People can figure out how to use it without reading the documentation very much. The #1 goal to have a really high-quality API. The second thing people mentioned, which kind of goes along with it, is matching the user's needs. Which everyone reported was hard to identify, hard to figure out exactly what people wanted this API to do and how they wanted to express it. So that was their kind of #1 thing that they had difficulty finding out that would help them with their jobs. They all recognized that consistency was a key goal, key problem that they had to solve. And hence, this was driving a lot of the guideline sets, because that is a big way of achieving consistency. We asked them what would be an example of a good API, and in terms of a conventional Java-style API, people mentioned Guava as an exemplar of high-quality API. And then for web services, typically people said Stripe, which is a financial processing API, was held out as being high-quality, well-documented, easy to understand, and simple. And interestingly, we asked people how did they learn to do API design, and virtually nobody had any training in this at all. That nothing that anybody learned at university, even the ones who had PhDs in software engineering, nothing they learned was relevant to the task of API design. That was a little discouraging. The key ways they learned was on the job. So more senior people said, oh yeah, we just tried a bunch of things and we learned what didn't work and learned from our mistakes, learned what people complained about and what ended up being hard to maintain. More junior people said they were fortunate to have senior people around to learn from, to apprentice with. Many of the companies used design reviews, as I'll mention in a minute, and they found that also very illuminating when senior people came and looked at their designs and told them and gave them feedback about it. Only one of all the people we talked to said that anything that was even mentioned in class was useful, and he happened to have a professor that mentioned API design and taught a few things about it in one lecture of a software engineering class. But other than that, nothing anybody learned was relevant, even though this is quite a large number of people are involved in this kind of task as part of their work in companies. And we asked them, is there some book or blog or discussion forum where you typically look for good information? And nobody really said anything. And certainly there wasn't any consistency amongst different people. So we were wondering how people organized their API design, what was the process that they used, and it was quite informal. You would imagine something as high impact as APIs might have a very strict or formal process. We did not find that. Many people mentioned having design reviews. So in companies, it seems like code reviews are a key quality, key way that they try and ensure code quality. Everything that's released is required to go through a code review. And similarly, the APIs had a design review. Sometimes it was the same review that the people doing the code review would also consider the API design as part of their review. They had occasionally did these kind of reviews of early designs, but usually it was the finished implementation. They, as I mentioned, there were all these guidelines. So you can imagine that the people who worked at the companies that had guidelines found those guidelines particularly useful as a way of trying to follow. But they also reported that occasionally they didn't actually admit this, but other people said that they weren't really following the guidelines, and so that was sometimes a problem. But besides that, there was really no standard process. That there really was quite a divergence of the kinds of things that people would do and the process they'd use. I thought it was really interesting that, if you think about regular GUIs, at this point, no major company is going to let their programmers design a user interface anymore, that they have UX specialists that do that kind of thing. This was not the case for APIs. The leaf engineers, the kind of lowest level engineers, were in fact empowered with making significant design decisions about the APIs. There's some companies that had product managers that would sometimes get involved. And one company mentioned the chief architect, which would deal with kind of architectural issues. But there still were many decisions that a leaf engineer would get to decide for themselves. And a little bit sad to notice or to identify that nobody had ever done or even heard of doing a usability evaluation of the API before it was released. They pretty much relied on beta releases. And so they would release it, and the beta users would give them feedback on the usability of their APIs. And that was kind of it after they did the guidelines and the code reviews. And also the documentation was typically written by the engineers themselves, and some high-impact APIs did have tech writers helping, but generally it was the engineers themselves. The key problem that people mentioned was backwards compatibility. They were always really worried about this because APIs with millions of programmers out there, if you change something, people are going to be angry at you. And an interesting piece of feedback was that people working in old-fashioned languages like C++ said that pretty much anything they did was a breaking change, that there's no such thing as a non-breaking change in C++ because people have visibility kind of in everything, and there's really no information hiding in something like C++. But we heard all sorts of stories about how people had unit tests that checked for the actual string of the error message. And so when they changed the error message as a result of a refactoring, then people's tests broke. The line number in the code that was exposed as part of the debugging message was being used by people. And so basically there was nothing that people could do that was a non-breaking change. And so that was really annoying. One group of people had at their had the availability for the entire code base of the company, and they were able to change APIs, internal APIs, and then themselves be able to change all the code that used the APIs. So they were less worried about API changes because they could actually themselves, API designers could be responsible for updating all the code that uses it. That sounds kind of scary because they're actually changing code. They have no idea what it does that uses their API, but it was related to me that it's less problematic than you think because they had good unit tests. And so the claim was that the API designer could change the code, recompile it, run all the unit tests, and if it all passed, then they were golden and they didn't have to involve the actual authors of that part of the code. So that still seems a little worrisome to me. What are the other challenges? And these are some of the things that we're working on for future research is what are the best design patterns for APIs? Do we have any way of talking about good things and bad things, especially for web APIs? What are the right ways to go? How do we help people coordinate multiple APIs? There's really been virtually no research on what you can do in terms of documentation or tooling to help people with putting APIs together. And do we need to invent some new evaluation mechanisms? At lunch, we were talking about, how do you evaluate if this new version of your API is actually better or not? Or is my API better than your API? How would you go about evaluating that? And finally, if you're a company, what are the best practices in API design? If you wanted to say that you are following best practices, what would that even be like? So if you're interested in this area of API usability, we wrote a nice overview article of what we've done last summer. That's the CACM article, kind of gives a nice overview. As I mentioned, we have this new paper that we just published on Monday that talks about the style guidelines, and then we have lots of other work that's on my site, on the natural programming site on API usability, but we also are maintaining apiusability.org, which tries to collect together a lot of resources. Just real quickly, I want to mention some other research projects that I didn't talk about. We're working on exploratory programming to try and help data scientists investigate things through code. We're working on a conversational agent through programming by example, so it's fun to get back to programming by example. I mentioned the work on immutability, and Michael has gone on to work on blockchain programming and trying to make that more usable, because that's really important these days. And then finally, I have a brand new project we just started on what we call Knowledge Accelerator to try and help with the process of gaining new knowledge and then keeping track of it. And many of these are fun acronyms, and some of them I went over, some of them I didn't, but if you like acronyms and gemstones, we have plenty of those, and there are lots more on my website. Naturally, all this work was done with my students or by my students, and so I have to thank them. I have to thank my funding people, mostly from the NSF, but also from a bunch of companies. And then I have to thank you for inviting me. Sure.
So your example about the transport.send message transport, I'm wondering if there's an instance of typing in the way you phrase the task. So for example, if you ask them to say, please use transport to send a message. In this sentence, transport is the subject, the verb is send, and message is the object, right? According to natural English word order, it should be transport.send message. However, if you say, please send a message via transport, all of a sudden there is no subject, and now the transport is now kind of like in a preposition phrase, right? Did you try alternate phrasings for the task?
Yeah, so as I mentioned in the natural programming elicitation method, that is a key problem, is not giving away the answer in the question. So typically we wouldn't have any phrasing of it. We would have pictures, we would have a list of functions or functionalities that are required. It's a little tricky, but we definitely are very careful to make sure that the question doesn't give away any of the aspects of the answer that we're looking for.
So I'm interested in the part about documentation of APIs, because as I think about it, the way I usually use an API is I'll go find an example on Google, get it to work, at least connect to the server and do anything, and then I'll go through the documentation and try to modify it. So I was wondering, with that goal in mind of I'm here and I want to get to a point where I can get this API to work, are there other configurations of documentation and examples that could get you there faster or maybe easier?
Right. And there's definitely a lot of work in that. So Google has something called their API Explorer. That's kind of on the front of their API page where you can try out API with different configurations and different parameters right there on the web without having to configure anything. And they did one of the papers they wrote was how people are using that. And it's not kind of, the most obvious use is not what you think of people actually doing that, but in fact, people are using that as documentation because it kind of shows you what kind of parameterizations make sense for this API. So companies are definitely thinking about, given that people are doing this interactively, what would be some interesting new ways of presenting it that aren't just PDF documents or web pages or whatever. And then certainly researchers have done some interesting work in this area. So Joel Brandt, who's now at Adobe, his thesis, oh right, he moved to Snap. And his thesis from, was it here or Berkeley? Here, yeah. He did this cool thing where he embedded the examples into the editor. And then, you got documentation and examples all in context, and that, made it the kind of explorations you're talking about more integrated. And so I think there's both commercial and research interest in, given the way modern programmers actually work, how can we reconfigure both exploration tools and documentation to be more effective? Michael?
I'm curious about the broader ecosystems of these APIs. I've seen in many cases, ranging from web toolkits to visualization to others, where you have the API, then there's an API client, and then someone writes some other API quote on top of that sort of repackages that thing, and then there's another one potentially even on top of that, and you get these either different abstractions or at least sort of different angles on the same question. So clearly you could do usability evaluation on each of these layers to try to improve them. But I wonder at what level does it make more sense, given the human-centered perspective, to stop saying, let's fix this thing and instead say, let's consider different kinds of users and build it at different points, different layers.
Right, and it's even more complicated because you have to also consider the tools that people are using. So IDEs and so forth can have a big impact on which of those is the most usable. There definitely is this whole ecosystem of different aspects. In some sense, when people are making wrappers around your client libraries, then that's kind of a hint that there's some problem with your client libraries. And so the companies are definitely very interested in evaluating why people are feeling like they need wrappers around their client libraries. But a lot of the stuff we were talking about, like automatic generation, and all of that about generating their client libraries, we definitely heard in the interviews that some of the designers in obscure languages were annoyed that the automatically generated client libraries didn't seem very consistent with the way their language would normally be done, because they were designed by people who were like Java experts. And so they would say, oh, the automatically generated client libraries are too Java-like. And in my language, that's really not the right way you would think about things. I think that's definitely a good area for future research of how can we make these client libraries better so that people aren't motivated to try and wrap them.
What was the general reaction amongst the people you interviewed to the existence of these libraries that wrapped their APIs? Mm-hmm. Were they like, oh, great, we're happy to have someone doing this in another way, or are they like, they should really just be using, they misunderstand what our API is for?
I don't remember much specific about that. The main thing is, as I mentioned already, that they use that as a signal that there were problems that they might want to address. And you have to remember that most of these, especially the web APIs, change quarterly sometimes. And so it's obviously a really big job for the third parties to keep up. And so they, that's also an issue. Stu?
Excuse me if you said it somewhere, but do you have an sort of order of magnitude size of the effect that you see anywhere in the systems by improving the APIs?
Yeah.
Are we talking about a factor of 10? Are we talking about a double? Or?
Yeah, it's really hard to measure. We'd get a factor of 2 to 10 improvement in time, but that went from 2 minutes to 20 minutes kind of thing, which really not that impactful. On the other hand, the work we did with SAP, in some of our experiments, it took programmers a week to figure out how to get 3 or 4 methods to actually work because they kept having to send emails off to somebody and waiting for answers because the designs were so awful that there was really no way to figure them out without somebody knowledgeable telling you the answer. And so in a better design, they could do that in 3 or 4 minutes. So that was a completely different order of magnitude than we could even imagine testing in the lab. And in terms of these companies, nobody would give me any numbers, but they all agreed that they have lost sales as a result of API usability to their competitors. And so I definitely had the sense that there were monetary measurements that you could imagine making, but they wouldn't tell me the answers to, that were the monetary impact of usability as they lost customers compared to other APIs that were more usable.
Do you think the biggest effect is likely to be in the error rates that come out of these things, or the time to code, or the time to learn?
Yeah, all of these are obviously interlinked. The Google guys have a phrase, I think it's time to 200, right? So most of the web messages, you get error rates. You get an error message return, 405 or bad, I forget all the code numbers, right? And then eventually you'll get a successful return, which is a 200 return from your HTTP message. And so, all of the bad messages were errors because people didn't understand how to use the APIs correctly. So I don't think you can really distinguish errors from learning because that's kind of fundamental.
We'll take the rest of the questions offline, noting the time, but please feel free to come up and chat with Brad straight after if you guys have a couple minutes. Let's thank him one more time.